Okay, so vectors apply to velocity, vectors apply to force. What else do vectors apply to? Well, vectors pretty much apply to anything that has magnitude and direction. For example, momentum. Let's consider the following situation. We have a 5 kilogram object moving at 10 meters per second in the x direction so that the angle of motion is 0 degrees. Positive x direction, 0 degree angle of motion. And let's say we have a 12 kilogram object approaching a collision point at 7 meters per second. Actually, the way I've got these drawn, it looks like they're going to miss each other. I should have drawn this over here further, but I needed room to label it, so cut me a little bit of slack here. Anyhow, the 12 kilogram moving at 7 meters per second at an angle of 212 degrees. So we're moving in this direction, 7 meters per second, 12 kilograms at 212 degrees. And for the heck of it, let's assume we're going to have an inelastic collision. We won't really make use of that idea until a little bit later. But we'll be able to find the velocity of the objects after collision, both the magnitude and the angle of the velocity. Now, the momentum of this first object, well, the first object here is 5 kilograms times 10 meters per second, or 50 kilogram meters per second, as we can see down here in the corner. And that is in the direction of the velocity. So we have momentum that we'll call P1 and put a little arrow over it to indicate it's a vector. This is the vector momentum of the first object. Its magnitude is 50 kilogram meters per second, and its angle we're going to call theta 1 is 0 degrees. We can represent that by an arrow, by the purple arrow here. Okay, that's the momentum P1. And we have a momentum P2. The 12 kilograms multiplied by 7 meters per second gives us 84 kilogram meters per second at an angle of 212 degrees. So that we see the momentum of the second object, longer arrow indicating that it's greater than the first momentum. It should actually be even a little longer than I've drawn it. I didn't draw it to scale very well. This should be in the ratio of 84 to 50 to this one. It should be 84/50 as long as this one. In any case, this momentum is 84 kilogram meters per second at 212 degrees, represented by this purple arrow. Now we do the usual thing when we encounter vectors. We calculate the components of the vectors. And by the straightforward calculation using the magnitude and the angle of this vector, we obtain that the momentum P2 has an x component of negative 71 kilogram meters per second and a y component of negative 44.5 kilogram meters per second. This is obtained by multiplying the 84 kilogram meters per second by the cosine of 212 degrees to get the x component, and then multiplying by the sine of 212 degrees to get the y component. So the momentum situation simplifies to what we have here. We have a 50 kilogram meter per second momentum. That's the total momentum of the first object, and the two momentum components of the second object, negative 71 and negative 44 kilogram meters per second, respectively in the x and y directions. We then get a total momentum. Well, what's a total x momentum? 50 kilogram meters per second this way, negative 71 in this direction gives us a total of negative 21 kilogram meters per second. The y component is negative 44 kilogram meters per second. So we have the vector diagram that we see here. The negative 21 kilogram meter per second x momentum and the negative 44 kilogram meter per second y momentum. We draw the rectangle and the diagonal vector, and that's going to be our resulting vector. We're going to get an angle that's equal to the inverse tangent of the y component, negative 44 kilogram meters per second, divided by the x, which is negative 21 kilogram meters per second. That inverse tangent is 64.5 degrees, and that should cause us a little confusion because 64.5 degrees, I can't really point, is up in this direction, back this way. Okay, back, I can't move my hand in that direction, but it comes up in this direction. And obviously the force is down in this direction, so that this is somehow opposite to this. We'll talk about that in a minute, but store that away. The total momentum has magnitude by the Pythagorean theorem, and you can see the calculation of 49 kilogram meters per second.